In this video, we are going to introduce our NeurIPS work on the game theoretic approach to class-wise selective rationalization, which is a joint work by MIT IBM Watson AI Lab, IBM Research, and MIT. To start with, let's first talk about what is selective rationalization, or rationales. A rationale is a hard selection of input features that are sufficient to explain the output prediction. As an example, here is a beer review, and the output prediction is the rating of the beer appearance. The rationales are short sentences that explain why the appearance achieves 5 stars. Despite their success, existing rationalization algorithms have one limitation. They only look for rationales that support the label class. For example, here is a hotel review that is negative. Then they can only find the explanation for the negative sentiment. However, what if we want to also find rationales that support the other class? In this example, the positive class, which we call counterfactual rationales. This would allow a more structural interpretation of deep learning models, much like humans' pros and cons weighing process, especially when the input evidence is complicated and mixed. Motivated by this, we propose class-wise adversarial rationalization, or CAR, that can find rationales explaining any given class. CAR is a game theoretic framework. For binary classification tasks, it contains 2 groups and 6 players in total. We will only discuss the first group, which is responsible for producing rationales for class 0. In this group, there is a factual generator, which generates class 0 rationales from class 0 texts. There is a counterfactual generator, which also generates class 0 rationales, but from class 1 texts. There is a discriminator, which distinguishes factual from counterfactual rationales. Both factual and counterfactual generators try to convince the discriminator that their rationales are factual. It can be shown that through this adversarial competition, both rationale generators are able to perfect their selection of the class 0 rationales. Here are some examples of factual and counterfactual rationales highlighted by CAR on hotel reviews, where we can see clear pros and cons highlighting. Objective evaluation on factual rationale annotations shows CAR achieves better accuracy in finding factual rationales. We also perform a subjective evaluation where the subjects are presented with the rationales and asked to guess the class as well as the aspect. The results show that CAR is able to correctly convince the subjects with factual rationales and fool the subjects with counterfactual rationales. To learn more about CAR, please refer to our paper. Thank you for your attention.